Moving on to our next presenter, next and final presenter, James Halgren. So Dr. Halgren leads cyber infrastructure research for the Cooperative Institute for Research to Operations in Hydrology, known as CIROH. With 20 years of experience in real-time systems integration for flood and flow prediction, he heads the CIROH Hydroinformatics Lab, guiding development of research accelerating technologies and computing facilities to support broader CIROH research goals to improve flood forecasting and water resource management. James, I will hand things over to you. Thanks.
And just quickly, let's make sure my video and audio are clear.
Looks good.
Great. Afternoon. If anybody's further west, good morning still, I think, if you're far enough west. As you mentioned, Jeremy, I work for the Cooperative Institute for Research to Operations in Hydrology here at the University of Alabama in the Alabama Water Institute. It's a little embarrassing. I'm following Chris and Ranjan. They're getting things done at a very practical, very real level in these two cities. I used to live in Fort Collins. I interacted quite a bit with Chris when I was at the University of Colorado State University. But where I'm at now, we're hopefully doing the things that will help those kinds of systems have even better information as we look into the future and the potential for incorporating new technologies and the types of things that will make those even more effective for preventing loss of life or harm to property. Get my mouse in the right place so I can zoom ahead. The Cooperative Institute for Research to Operations in Hydrology is tightly coupled with the National Weather Service and the United States Geologic Survey. We look at problems at all scales. We look at these high intensity events. Some of these you've seen pictures of from the previous presentations. We look at issues of variability and the increasing variability that affects water supply. We're looking at water quality issues as well as massive scale issues. As you look in the bottom corner of the presentation, bottom left, the HABs issue is a matter of looking at a giant area of the United States and how it influences the biology of the Gulf. And then, of course, the human impacts is a major part of what we do, just making sure that when we're doing research, so the name of our institute is the Cooperative Institute for Research to Operations. And our goal is to make sure that when we give something that's a research product over to our operational partners, that it's something that's useful not just to them, but useful for them in their communication so that they can actually do something that has an impact for an individual that's trying to make a decision whether or not to walk in water, drive around water, etc. The idea is really cool. The classic divide is a critical thing. We sit here in I'm in a university research building, and I have an office, and I come up with really good ideas, and they all work every time in my little research watersheds, and there's this giant divide over to the real operations. You know, the places where data doesn't come in just right, hasn't been QC'd in the right ways, where there's questions that we haven't considered. And the goal is to bring together the operations and the research folks through this Cooperative Institute and see if we can't accelerate some communication that will help things out. This is me right here. I'm literally just inside of that little window right there. And we are co-located next to the hydrologic instrumentation facility. Every USGS gauge that's being used today is going to be, this facility was just opened and they're now transitioning over here from their older space at Stennis Space Center, is going to be tested here. And if it breaks, it comes back here to be recalibrated. And then the operational component of the Office of Water Prediction at the National Water Center is housed in a building on campus here. And we're working with them to improve the prediction of flooding and water resources across the country at a high resolution. So the co-location here is hopefully accelerating those things. We take advantage of it and have meetings and talk with these guys actively. And our consortium of 28 partners encompasses the whole country. And so hopefully we're allowing for that integration to not just help us out here at the University of Alabama, but across the whole country. And if you have anybody in any of these institutions that you know a little bit, you can ask them about CIROH and see if there's a way that you could connect and start to participate in some of the things that we're working on. We are trying, as I mentioned, to get the actionable water intelligence into the hands of people. This is a fun little mock-up of a possible web app that some people have developed. We're looking at all these different sectors. Transportation is one that I'm exploring individually in a project that I have that ended up connecting me with this webinar. With a group that are looking at road weather impacts specifically in the southern states, and then of course across the spectrum of other applications. CIROH is 3 years old almost, not quite, and we have a 5-year initial grant, and we expect to extend that to 10 years. So we're accelerating. Here are some of our current stats, and like I said, please feel free to connect with somebody in one of those institutions, and let's see if your question, your research question, could be something that we take advantage of our graduate students and other research staff to accelerate and find a way to connect it back into operations with some force multiplying by our group. Our research is divided into these 4 research themes. I'm going to take just a moment and highlight some actual things. So this is all high level so far. Let me show you some of the things that we're doing at a ground level, and then I'll finish out these slides with a couple of things that I'm working on individually that are probably hopefully directly impactful to the broad community on the line here. We have community water modeling development, which has to do with improvements to models. So somebody that has a new way to model water would be attached to our first research theme. The groups that are bringing together many different pieces to simulate large systems and bringing in the observations that are associated with those large systems and doing the data assimilation, that's our second research theme. So our direct connection to the national water model, for instance, is through this research theme 2. Hydroinformatics is all of our work to make the data and information understandable and get it out in front of people in ways that they can use. And then the last is our social science element, making sure that we're thinking ahead about how people react and making the information promote resilience rather than simply responsiveness. Our research theme 1, on the right, we've done a number of studies regarding machine learning based analysis across the continent. We've taken advantage of some of the work that's recently been done with machine learning and accelerated the capability so that we have some demonstration models with improved capacity over the whole country, and we're looking at finding ways to bring those into the operational models with explainability. That's one of the critical things people always say, but if the machine learning model can't tell me how it got its answer, how do I trust it? And we're expanding that group at the Penn State University has done some significant work advancing that. We also have a group from Stevens Institute in New Jersey that's done a lot of work with ice and the ability to model for the northern regions what will happen. How do we predict the flooding and impacts associated with ice jams and rivers and their timing of their breakup, and using pretty amazing remotely sensed information to predict and manage those situations. Research theme 2 happens to be one of my most active areas. We've developed a community infrastructure so that somebody can take the national water model and snip it out for their area and fairly quickly be running a version of it on the laptop and start to do experiments and explore what their outputs would be. A number of different additions to the framework, expanding the models that are currently in the national water model so we can explore what would be the impact if we transition to different types of models. In the hydroinformatics area, we have a number of data sets. If you go to portal.ciro.org, you can start taking a look at some of the things that have been posted so far. And as we reach our developers conference this May, that there will be a number of new things posted there as we're sharing our work with each other. And then in our science meeting in October, those things again will take another leap forward. So if you are interested, you could poke into portal.ciro.org and see some of those advances and what we're sharing there. And last of all, our social science areas, we've been and looking at the ways that these things impact beyond just the water. A number of our flood preparedness initiatives and resiliency initiatives in a number of areas, especially in the Mississippi River Basin, and the impacts that those things have on actual people when you integrate the national water model into planning, which is one of the big studies that we've been working on. Because we're a university, we do education. These are student programs across our consortium, master's and undergraduate and PhD students, and they have access to these facilities that we're co-located with, and also tours across to the different facilities that have interest with our operational partners. So the TVA in the center, in the middle there, one of our students presenting at AGU, and the flow tank, the wave tank at the USGS HIF. These are all things that our students can take advantage of in the RFCs. What do I do? My group is in charge of docs.ciro.org, where we document in a very straightforward and constantly growing way the capabilities that we're building out as a CIROH organization. Go ahead and check it out. I am part of a group that's doing flood inundation mapping work at regional scales. This is the cooperation with the University of Kansas, where they have a flood mapping dashboard right now. Today, in this very moment, there's a small amount of flooding on this river, the Lightning Creek at McCune. That same flooding is modeled in the National Water Model's flood inundation layer, which is a recently released capability from the National Weather Service. Hopefully in part 2 of this webinar, we'll get to hear more from the team that's producing that. But we are part of the research group that's looking to advance that with some of the techniques that we're developing here. As I mentioned, I work with the capability to help people get into use the National Water Model tools. We've developed what we call Next Gen in a Box. So the Next Gen National Water Model, or it's the Next Gen Water Resources Modeling Framework. We've containerized it, and we've got a workflow that if I sit with you, probably within about 5 minutes, you could be simulating the water flow in your watershed just with a few clicks. And then you could go from there to see what you want to experiment with and adjust and try some new things. And that won't take 5 minutes, but I can promise we can get you started in 5 minutes. That's our commitment. So we're cooperating across a whole bunch of different agencies: the Corps of Engineers, the Ocean Service, of course, NOAA, and all of the NOAA agencies that were part of NIDIS for drought, and anybody else. And I clipped this in here. This is the Federal Highways link, and I hovered over it and put it into my slide deck so we could talk about all the others that we would like to connect with. So come on down and visit us in Alabama, or give us a call and roll tide.